creating that particular thing that you use in your day-to-day life, such as database, programming language, message brokers, anything is the greatest way to learn something, right? If you are starting your tech journey, then creating your own programming language, kind of toy programming language, would open up many opportunities for you to know how things works internally, and this curiosity helps you a lot in the long run, right? So let's learn how to create our own programming language, or let's say the compiler, right? We will create something like Python, right, having that interactive cell, right, so that we can just see the result, intermediate result, in our console. Let's go to the internet and just research how compiler are designed, right? uh, let's search something like compiler design. Okay, let me turn off the distractions and let's get started. According to Wikipedia, a compiler is a computer program that translates computer code written in one programming language, which is source language, into another language, which is the target language. For example, if you are writing some code in Python, or let's say Java or C Sharp, and eventually that particular language code is converted into the machine code or the binary bits, so that the CPU can understand it, and it can provide us the output, right? It can be called as the kind of a middleware or the virtual machine that does some kind of work in the backend, right? So we will quickly see how to make that thing work. What are the layers of the compilers that converts the source language to the machine code, right? If you can see this article, a compiler is likely to perform some or all of the following operations, often called phases, right? Pre-processing, lexical analysis, parsing, semantic analysis, syntax directed translation, conversion of input program to an intermediate representation, code optimization, and machine specific code generation. Are we doing everything? No, we are just trying to create some kind of simulation or the replication of the programming language, so that we will at least know how programming language are created from scratch, right? The language that you use in your day-to-day life, what if you know the entire implementation? You can even go to the GitHub, and you can even contribute to that specific favorite language. For example, if you are from the Python background, then you can just go there and improve the particular language, contribute, right? If you are into C Sharp, then you can always contribute to the runtime project of the .NET, right? It's up to you. It depends up to you, right? Okay. We have already seen the phases. We have to study more about these phases. It says lexical analysis, parsing, right? Semantic analysis, intermediate representation, and all, right? Compilers are not the only language processor used to transform source program. Intermediate interpreter is a computer software that transforms and then executes the indicated operations, right? Let's go step by step. Let's just let's just see this diagram. It explains a lot, right? Source language, lexical analysis, parsing, and all. I feel lucky because I know the concept of lexical analysis to some extent, because I have worked on NLTK package, or the library of Python programming language for natural language processing. So lexical analysis is nothing but the process of tokenization, where we extract the tokens, meaningful tokens, from that specific programming language, right? Let's just duplicate this tab and let's just quickly see how lexical analysis works in programming language. Okay, lexical analysis. lexical tokenization is conversion of text into meaningful lexical tokens. That's all. That's all is the concept of tokenization, right? Conversion of text into meaningful lexical tokens. What could be the meaningful lexical tokens? For example, in any programming language, let me just open my terminal and create a basic project for our toy compiler or interpreter, whatever you want to call, right? So let me just move to my desktop, create a new programming language. So we should give some name to our programming language. I'm very bad at it. What should we give to our new programming language? Binlang, bash. We already have bash, right? Server lang, desktop lang, hash. Let's say hash lang. It's so randomly given name, right? Okay, hash lang. Let's create new console so that we will get our starter kit for our .NET environment, right? And we will see how tokenization actually works. Let me just open this code editor. Okay, we have, I don't understand why we get this type of text editors. Okay, we have program.cs. We are not going to refactor it. We can, but let's make very basic implementation, right? I have heard somewhere make it work and then make it pretty. It's very easy to make your project pretty. Let's just make it basic implementation, because we are not designing some kind of production level programming language. Like, it's just for our learning purpose. It's not a production ready programming language. Okay, so what happens is, let me just create the basic readme.md file so that we will just understand the concept. Okay, so in any programming language, we will give some script, some lines of code. Let's say, for example, let x equals to 4, right? X equals to 4. Then eventually we can represent this entire thing in a list as of now, right? As of now, and we can just break down that specific thing into some meaningful tokens. What are the tokens? Tokens are nothing but just the extraction of this entire sequence of characters. Let's say let x equals 4, right? This could be a meaningful lexers or tokens, because it has some meaning, right? Let has some meaning, so it is the data type that we are giving to the programming language so that it can execute our entire thing. X can be an identifier, this can be an operator, this can be some literals or numeric, whatever you would like to call, right? So okay, we'll just delete this, right? This is the entire concept for this. Okay, let me go to the lexical analysis. Like those categories include it's like the natural language: nouns, verbs, adjectives, punctuation, etc. Right? You don't have to read everything. Let's one of the best way to read any kind of doc is to first read some first line of first paragraph of that article, right? Read this loud, right, without skipping anything. By the time you will become more fluent in reading the docs or articles, then it will eventually become, you will scheme the words, right? Lexical grammar, scheme the words, scan the entire paragraph. It comes with experience or the practice, but at first you can just quickly scheme this entire paragraph, like what it is, right? And after that you can just go to some tables or figures. It makes life much easier. If you have some kind of tables, then you don't have to read anything, right? Okay, identifiers, as I've already mentioned, this human given programmer assigned value to some particular methods or the variables can be called as identifier. Keywords, separators, operators, literals, right? Comments, white space, anything. And this is the expression in basic C programming language. x equals a plus b times 2 semicolon. It can be expressed in lexical analysis. It can be expressed something like this: identifier x operator, something like this. You can just read this out, right? And after this, after writing the lexical analysis, we will just write some kind of rules for our programming language, like how the entire tokens get used somewhere so that it can give some meaningful results or something, right? If we get some operators, then just do some kind of mathematic operations such as addition, subtraction, division, or anything. Like you have to handle the case for the zero division, or you have to write some kind of exception methods and everything. Like just remember the edge cases, because if that breaks, then your project can be brutally hurted. Okay. Nice. Lexicon analyzer, parser. So you can just read something about parser, but yes, as of now, just write let's write basic lexical analysis, so that it will be step by step implementation, so that won't be some kind of overwhelming or difficult for us. Okay. If you are writing any C# code, you can write this in any language. If you are from Java background, then just follow along with this. It's just very similar. Even if you are using the Python, you just have to care about the logic building part. You don't have to care much about the syntax and all. Everything is so simple. We're not using some advanced library syntax or anything. So you have to explicitly remember that thing. We're just using the basic programming concept, so it is applicable to every other programming language, right? Even if you use JavaScript, that's totally fine. Namespace hashlang. We're already 11 minutes. Public class program static void main string args, right? Okay, what we are going to make, right? Let's make something like R programming language. If you are from R or Python background, then you might know that we can just replicate something like this in the interactive cell. Okay, something like this, right? Something like this. If you write something like this, print hello, then if you hit enter, then it gives something like hello was entered or something. And if you write something like this, let x equals to 4, and it says like x equals to 4 was assigned. And if you print x, then it will just say something like 4 or whatever, right? This can be the basic implementation. We are using one programming language to create some representation of other language, so that we can play around. You can, instead of let, you can give some kind of other things. You can just control your language, right? So that will be the benefit, and you will understand how things works internally, in a high level. Okay, so for this, and also we have to stop this cell if user types some kind of exit or anything. If user give empty space, white space, then let it ask again, like unless and until you enter exit or something, then that should work. You have to create some of the handle some kind of edge cases for this. Okay, if you are from some competitive programming background, then you might have written something to handle any number of test cases. We have to write some kind of loop, and unless we have all those test cases, then that entire program execution will exist, and if the test cases ends, then the program stops. For that we have to loop infinitely, and if user clicks or types exit, then we have to get them out of the entire program, right? Okay, console dot write line, I can just write something like, hey, welcome to hashlang. We're not writing any concept of hashing, it's just a random name. Okay, type exit to quit. Right, let's go to the R programming. Let's see some images. I've seen somewhere like we have some kind of things, right, like this console something. Type Q to quit. It has some licensing and all those things, right? It's not clear as of now. You can just open some other images. It is mostly used in statistics, data science, right? Okay, this is the like way like Excel or Python interpreter something. Okay, something like this. This can be the exact representation that we can start building today, right? Something like this. That won't be fancy. We might require some huge amount of time. We can probably do that in some kind of live stream or something, but yeah, for now, for this recording purpose, let's make it little short. Okay, while true, console dot write. We have to take care of this case. Okay, the representation, and we will just ask the user input var input equals to console dot read line, right? If you are from Java background, then you will just write Java import java.util.scanner, and you will just write assign new scanner for user input, right? If you are from Python background, then you can just directly write something equals to directly input equals to there was something, right? User input equals to input something, and you can just directly hey, write something just pretty simple. Okay, now what we're gonna do, we'll just write some kind of edge cases for this. If string dot is null or white space for this specific input, continue, right? If input dot true lower equals to, if user types some value exit or q or anything, just write exit as of now. Then let's break it, right? Okay, it looks promising, and we'll just write we'll just call our lexers or parser or any evaluators or whatever into this try block, and we'll just write gas. Have some habit of writing exception handling so that your server does not crash. It's the good way to start something, but we're just writing some basic representation. Okay, all right, something went wrong. If you don't know, if you cannot think of exception message, then just write something went wrong and call that ex.message, right? You should also learn some concept of logging are really important monitoring tools. There are many things. I can use Datadog for this, for some larger projects. There are several ways. Okay, we have written our basic input output implementation. If you are from some kind of competitive programming, if you have solved some code safe problem, then you might have you have definitely implemented this kind of things, like while the input number n is something greater than 0 or something, that run this program, else break, something like this similar. Okay, so what we're gonna do now, we will just see the lexical analysis, grammar, fire, like this. How we gonna store this thing, how we gonna store this specific thing for this, how to do this? First of all, we have to declare some kind of list for this, right? List and equals to list, and we have to run some kind of loops that parses this string, that runs through this string, and after that we have to break down that thing to extract those characters and do according to our necessity. Okay, cool. Static list, I have to return the list, so that we are just returning the list type string, say lexer or lexical, let's just say simple lexer to be more specific. String input, we will be using the user input that we have. Tokens, we will just store that tokens into the list. String, okay, there should be current token that that can be utilized inside the for loop. Current, or you can just just write current. Let's write clean code approach, or it's just say the meaningful names for methods and variables, right? So that you don't have to write large number of comments in your code. Just make your method or variable names proper, so that you don't have to write the comments, code comments. Okay, so this will be at start, of course this will be empty. For where, you can just write ch here, but I will just write where for this. Input, okay, for each. If you are from Java, then you can directly write for C#, we have to write for each. Dot is white space ch. Okay, if it is white space, if not, we're just covering some edge case. Null or empty. Current token, okay, tokens dot add current tokens, and we have to make this as empty again, right? Cool. What next? I have to write some kind of another condition that particularly works for that operators, such as plus, minus, multiplications, or the equals to sign, so that the the compiler can understand, okay, what you have to do, because you have to separate the other things as well as the operators into the two different parts, so that it will be easier for us to later implement the parsing logic. Else if ch equals to okay, alsc, else, or ch equals to plus, ch equals to minus, ch equals to division sign. String dot similar thing, string dot is null current token, and test the similar logic. So you can just tokens dot add current token, and current tokens equals to string dot empty tokens dot add ch. Is it enough? No, because tokens hold the string data type, so you have to convert this to string. Okay, I think that's cool. What else you have to do? We have generate. Okay, you have to return the tokens. Basic lexer is done. So in real world, you will have multiple things. Like instead of this equals to, we could have separately implemented the structure for this to identify all those keywords or identifiers. But okay, we're already inside the method, right? Okay, we're in the for loop. We have to return this outside for loop tokens. Okay, cool. Let's just quickly example lexer equals to, let's call that thing simple lexer, and pass input inside this. Okay, this looks good. This looks good. Should we push this change to GitHub, or let's just push everything at last? I think it's very simple, like 15-20 lines of code. It's not that much complex, but oh, haslang. Okay, simple lexer, and I think we can just write the basic parsing logic, so that it will be easier for us to write the evaluation metrics. Parser. Let's see what parsing is. We have to find some kind of tables or expression so that it will be easier for us to convert that into the specific code, right? Process of analyzing. Okay, analyzing string of symbols. We have already extracted that thing and pushed that entire tokens into our list, right? Okay, do we have some kind of expressions? Okay, the first stage is the token generation or lexical analysis. We have done it, by which the input character stream is split into meaningful symbols defined by a grammar of regular expression. For example, a calculator program would do something like this. These are meaningless, these are meaningful. We have to write some kind of thing. If you want to study more, we can learn about the context grammars for this. That will be so I think it is entire one chapter for the university courses. If you have studied some kind of theory of computation subject, then you might have already known about this thing. I remember my college days. I was very bad at it. Okay, there was some kind of it was okay, something like this. Following secrets can be derived, something like this. Okay, we have some trees, right? Abstract syntax tree. Okay, this is called parsing tree. Abstract syntax tree. Rightmost S plus A. Okay. You can definitely give one short for this. I will just quickly copy its URL and paste this to the readme.md, so that it will be easier. I'll paste everything. Parsing. Just try to implement these things by your own to practice basics of programming. by creating your own basic simulation of it. Okay, let's just separate the argument and inputs, right? Let's just work on that specific keywords that we have defined here. Static void static, or you can just return commands and args, so that it will be easier for evaluator to evaluate something, right? String command list string args. Okay, parser, of course we have a list of tokens. You should have the list of tokens, right? It is the second step. Okay, if just write some let's just write some edge cases. Before writing any code, just think of the edge cases. What if we don't have any tokens, right? There could be some scenarios, right? We don't have any tokens, so you should always write the edge cases. Tokens dot if we are inside the list, then we have count method equals to 0, throw new exception, no input, or just please please provide input. Okay, okay, so what could be the next step? Okay, let's just if we don't have any if we have the counts of token 0, then of course we will be having other things, right? String commands command equals to tokens 0, right? And args would be the other things, right? We can, in Python we have the method of slice. In C# we can have some kind of get range method. Get range from first to something tokens.count -1, so that it will just include from second to last element, count -1. Okay, just return this thing, command comma args. Okay, this is the basic representation. We will just do debug it in electricity, so that to see what is happening inside, right? Okay, I've written 80 lines of code with some white space. I'm having some problem understanding what should we do to these things. There are many parsers called register handler callbacks. As soon as the parser detects relevant tokens in the input stream, push parser may skip parts of the input that are irrelevant. Typically used by compilers front ends by pulling input text. Okay, let's see this. Source string, let's create token create tree, parse tree, translator. Okay, I think we have to write some kind of grammar for this. What happens if what happens if we write let? What happens if we write some kind of thing? Let's work on command at first, and let's use that command to work more on the argument. For that reason, I have separated the command and the argument parts for this. Okay, it makes sense as of now. Okay, okay, evaluation. How they are writing these things. Compiler any programming language. Python, we have Python. GitHub. I just wanted to see some ask clues for this. Okay, pseudo lang. Pseudo API translator, idiomatic target language. Okay. Oh, they're doing like this. It's a bigger project, I think. How we gonna write the grammar? We have commands, we have arguments. Arguments are written at the situation where you don't have the clear idea of how many parameters you will be using there, but I have to think for a while how we are going to do these things, right? We have to utilize this entire thing. Let's work something like this. Let's work on variables first, right? Let's go step by step. Okay, let's evaluate the parsed command first. Static void evaluate string command, a list of string arguments. Okay, we have two different things, so that's why for inside this parameter we have used the braces for this, commands and args. Parsed input. Okay, do we have any cases for this? Let's just extract the command to parsed input so that it will be easier. Dot command, we should get dot command where args equals to parsed input dot arguments. Okay, let's we can write if else, since in future we might have many commands, right? We don't have to do anything now. We just have to write the specific work of that specific commands, right? Specific work of that specific commands. So I think it makes sense. It makes more sense to use a switch case. We don't want to nest all those logics in the long run. If we use case break, then if the logic grows, we can just refactor it. We can just define that thing in some kind of helper methods and just call that thing out in this specific file. We can even write separate class for that evaluation logic. So I think we should just write switch case statement. You should know this use case of the specific commands, so that I strongly urge people to create some kind of projects, right, after learning, because we are just using basic C# code. There's no any advanced topic right now. We haven't used we just have used basic data structures list. We have used methods, loops, conditional statements, break, exception, basic things, right? Okay, there should be some case. What should we do? Should we make some kind of fun by giving some dummy representation for the data type, or just write let, right? If this session was in Nepali language, then I could have used some Nepali language, like say Rakha or Dev or anything. Yes, let if args dot count is of course that should be greater than 3, right, or equals to 3. It's not possible. Is it possible? Let equals to 4. Okay, 3 or args 1 not equals to yeah, it makes sense now. 3, then throw new exception invalid text for variable regression. Right, you can give some meaningful error message where variable name equals to args 0 now. For expression equals to args dot, yeah, of course same old method, get range. Yeah, from we're skipping that equals to sign now. Args dot count minus 2. Okay, where I have to write the method. Okay, oh, you have to write another method that does something, right? In case of let, just like break as of now. Let's work on the print statement first. Let's print something and then just if similar thing, args dot count not equals to 1, right? If it's not equals to 1, then throw new exception. Okay, variable name set to undefined or something. Variable name, okay, just write something like this, undefined something, or just write invalid syntax for print, right? Okay, it makes sense. Let's not complicate things. Print me args 0, right? Okay, print me args 0. Should we write the uppercase print or the lowercase print? You can even write anything that we want, but let's write very basic print statement for this as of now. Okay. If print me dot starts with, okay, you should know the concept of basic strings, right? Okay. And print me dot ends with I hope it works. Console dot write line print me dot trim okay, to trim something. Cool. Else, in the else statement we will just else in else we can just directly throw exception undefined variable print me. Write new, throw new exception, and else if okay, in case of else if we should write some kind of variable name, variables. Okay, yeah, that would be enough. I think we don't have to write anything. Okay, we have to write the break statement first. Break. Can write the arithmetic operation. We have already written something for the print statement as of now, but should also write something for things. But at first should maintain some kind of hash map or in Java, or dictionary in Python or C# before starting our entire thing. Should make static thing so that variables and the objects are stored in the dictionary. Object variables equals to new dictionary. Okay, similar thing. Okay, makes sense now. Okay, so after the things will get trimmed out if it starts with this, right, string literals, else if variables dot, we have dictionary, right, get value, something was there, get value or something. No, it's in C#. Okay, contents. Okay, contains value. Contains key. We have just key as of now. Print me. Okay, we're just storing these things in hash map. Console dot write line variables equals to variables print me so that it will give the specific value. Yeah, it gets very difficult if you switch between different language. Okay, what should we do now next? Break case, print break. Let's write something for default case, right? Throw new exception unknown command. Yeah, cool. Okay, we have written our logic for the print, right? The one of the most difficult part is the for operators, how this entire operator things works. How to write evaluation matrix. Let's write very basic one, so that it will not be much difficult, right? Okay, we have already 51 minutes into the clock. Evaluate expression okay, same old things. Expression dot count equals to 1, right? If in dot try parse expression 0 out int value, then value. If variables dot contains key expression 0, then return int variables expression 0. Okay. Okay. If it has some count equals to 3, let x equals to or x plus 0 1 2 0 1 2 3. Okay, left equals to okay, we have to get the specific value for this. I think we can just directly write here also, but I don't think we should write this get value method here. We should write separate function for this. Oh, it's getting so complex now. Okay, specific expression for this, and we can write our own value to specify that thing. Okay, static int get value, we have 54 minutes. String token. Okay, I have token. If in dot try parse specific token comma out int value, right? You can learn the concept of out keyword. go to the docs or follow my blogs. I have already written in-depth tutorial on this. Return value if variables dot contains key token, then return int variables dot or variables token. Throw new exception, undefined variable token. Token can be undefined too, right? Okay. So that we can get the value. If it contains some kind of token, then we are just parsing this thing into the integer form. We are using the in.try parse method in C#, converts the string representation of a number to its 32-bit signed integer equivalent, right? It is for our own good, right? So if expression.count equals to 3, then let's do something like just like mathematic operations, like let's get value and expression 0 where operator or operand operator okay, symbol symbol equals to expression 1. Yes, we have expression 1 here. If you can see, we'll just definitely see this one, right? Where right equals to get value and expression 2. Okay, now you can just directly return operator symbol switch. Let's do basic operations here. If it is plus left plus right minus left minus right. If it is multiplication, left time right. If it is a division, right divided by left, or okay, say if we have to handle the 0 division case, should we? Of course we should. Okay, if right is not equals to 0, and use some kind of ternary operators for this. If not equals to 0, you can just directly ref by right, else throw new exception 0 division error. Okay, at the end throw new exception invalid expression format. Let me check if it works or not. .NET run. I like this code editor because if there will be some kind of compile time error, then it tells me, maybe because of some extensions that I'm using. But it's taking some time. Okay, there is some problem. Welcome to Hashlang. Cool. Should we okay, I'll just write print hello. It's not printing. Let x equals to 3. Okay, it's not doing anything. Okay, might run into some problem. Oh, because we haven't called the parser in our main method. var parser. What does it expect? We have to use a parser. It has list of tokens. We have to write the list of tokens here. What are our list of tokens, right, inside the specific main methods, right? What are the tokens? We have already these are our tokens. Okay, just write tokens here. It will be more easier to relate. Tokens. Okay, parse parser parse evaluate parse. Okay, let's just see this thing in our terminal. .NET run. Welcome to Hashlang. Type exit to quit. We don't want to quit it now. Print hi. Something went wrong. Please provide input. Okay. Let x equals to 4. Okay. Let y equals to 3. Unknown commands. Let's do some kind of debugging here. Something went wrong. Okay. Parser tokens simple lexer input. You can just write the statement exit. Exactly. You can just write break. Control dot read line and variables new dictionary string objects. Let's revisit our lexer logic. Input string new list string string.empty for is there character in input char dot is white space. Okay. It's not string in not current token tokens dot add current token string dot empty else if equals to ch. We have everything equals to plus up to division, right? String null or empty current token add string dot empty. Could be the reason tokens dot l. Okay. Oh, we haven't written, we haven't added the character. Okay, we cannot do this kind of mistakes here. It is a traversing, but it's not combining things, right? Current token is always empty, so not do this. Why it is taking so much time to load? We're already 1 hour 4 minutes into the clock. equals to 4. Invalid syntax for variable declaration. Okay, let's see this. Might have done kind of minor mistake. Might be some problem in the parsing command. Parser list string tokens. Goods is 0. Please provide input. That is cool. Command equals to token 0 arguments. We're just getting very simple things, right? Tokens -1, returning this thing. Evaluator, past input. Command list of arguments for this. Pass input dot command, pass input dot args, switch command. Let 3 the syntax for variable declaration. Get range expression. We have variable and expression. Oh, we haven't represented. Okay, it's of no use. It's of no use, right? Variable value. We have to utilize those things. We have stored something, but it's of no use. But even our print statement also not working, so we have to see this. Value expression. We have this. Respecting expression. What could be our expression for this? We already have expression. Value. Console dot write line. Variable name set to right value set to value. Console. In JavaScript you use lowercase, in C# you use the uppercase. But even if we are writing something but it's not working, starts with what could be the reason? What could be the reason for this? Let's run. Let's run this one. Let's see. Oh, there is some mistake. Something went wrong. Let x equals to 4. Invalid syntax. Something went wrong in the variable declaration. Here itself. What happens? Let's try to debug this one. We have tokens, right? We have tokens in the first place itself. But why it is not working? Parsing? Something wrong. Okay. To F11. Arguments. Okay. Invalid syntax. By any reason, we are not getting inside the evaluation matrix. Value return value variables contains key token return int variables token define variable token. Problem with parser. String command list why this list of string arguments acting weird. Command arguments. Let's see if this brings some kind of thing. Inside the print also we're getting some kind of issues, I think. We don't have arguments, that's the issue. Parsed input. That is the main issue we have right now. Let's debug this again. Let's see from where it is failing. Have you written something for the equals to sign? Okay, we have tokens. Parser. Let's go to inside the parser. And have 0. We have arguments. We have command arguments. minus multiply divide string current token string dot empty for each var ch in input character dot ch current token tokens dot add current token string dot empty else if 1 2 3 4 5 string dot is null or empty current token tokens dot add current token add string else. Okay, we can also write something like this right here. Okay, for each not string dot is null or empty token tokens dot add current token right .NET run. Okay, nice. Goes to 4 print okay, there are still some problems. Let y equals to 5, let z equals to x plus y. Okay, kind of things, some kind of basic things are missing. There's one command args here. Here is some problem in this case. Let arguments dot count -2 expression value expression evaluate expression. Oh, we haven't sent this value somewhere, right? Haven't sent this variable variables variable name goes to value. Okay, hopefully this should work. If not, I have to stop the video. Already it's been 1 hour 19 minutes. I don't have much time to debug this. Let's see if we can do this. Hell lot of exercise today. Print hi. Let x equals to 4, let y equals to 5, let z equals to x plus y. Okay, print z. Here we are. Okay, here we are, right? Print has lang. We did it. We didn't. I think it only supports the input without space. Slang. We did it. Okay. Thank you so much, everyone. I'll just push this code. If you we can, yeah, obviously we can just add something like case, if what does this do? We can just add the conditional logics for this, but due to constraint of time, we spent a lot of time here and there. Have to stop the video now, right? Thank you so much everyone for this.